You don't need to know physics to follow its laws. The average Iowan maybe won't prioritize a fundamental understanding of, say, quantum mechanics or relativity when faced with the more routine functions of the day-to-day. And that's okay, because these topics aren't exactly applicable most of the time. Most of the time. I'm Lorian McAnulty, reporting for the Drake School of Journalism, and today I'll be addressing the topic of everyday physics, the physics that every Iowan is expected to know. But before I go into that, I want to talk a little bit about how humanity just incorporated quantum mechanics into the global trade system. On November 16th, earlier this year, representatives of over 60 nations agreed to change the definition of the kilogram, the international standard unit of mass. Initially, the kilogram was an arbitrary hunk of platinum iridium, preserved in a locked chamber in the basement of the International Bureau of Weights and Measures in France. But now the kilogram has transcended its earthly bondage. Like the other fundamental SI units, it's based on a fundamental constant of nature. It's called Planck's constant. For all numerical intents and purposes, Planck's constant is defined as 6.626 times 10 to the negative 34 kilograms times meters squared per second. In plain English, it's a really small number with units of mass, time, and distance. So if you already know the values of the meter and the second, you take those numbers and rearrange Planck's constant a bit, and voila, you have the kilogram. There are many fundamental constants in nature, and they seem to come out of nowhere. You're probably familiar with pi. The speed of light is another. From what physicists have found, these constants are values that the universe seems intent on using for whatever reason. Planck's constant is no exception, but it surfaces in a very unique manner. Planck's constant emerges at the birthplace of quantum theory.
I love theory, and I could talk to anybody. I could talk to you about things that are theoretical and that have no immediate connection to anything that I'm doing with great pleasure.
That's Deborah Victor. She's a science teacher at McCombs Middle School in Des Moines, Iowa. And she's also currently teaching her students about the properties of waves, like those of the ocean, sound, and light.
We can look at water waves in a tank and what it does to the things that are floating on it, and how it doesn't really move the things that are floating on it back and forth, it moves it up and down. We can look at frequency of, not look at, but listen to frequency of tuning forks and understand how a higher frequency works. Away from you. So you're going to tap it and listen to the sound in both those places, but you're going to put different energy into it. So how can I put different energy?
So these middle schoolers are learning how sound behaves like a wave. And since Victor is following the next-gen science standards, which are the learning expectations that the Des Moines Public Schools adopted last year, eventually these students will learn the same about light. Light behaves like a wave. It has a wavelength, it vibrates with a certain frequency. And by the end of their public school careers, these same students are expected to understand how light also behaves like a particle. Light has momentum, it holds energy. And that's exactly where quantum theory starts. Light behaves like both a wave and a particle. It's at this boundary, this threshold between light wave and light particle, where Planck's constant makes its very first appearance. So that's great. But what other topics in physics are Iowan students supposed to know? To find out, I spoke with Chris Kilabarda, the science consultant at the Iowa Department of Education. Kilabarda said all science standards in Iowa are outlined by Next Generation, a national interstate collaboration that evaluates the state of science as we know it and determines what American K-12 students should know. Iowa, as a state, adopted these standards in 2015.
These standards were really designed as the purpose behind it was, what do you need in order to be college career life ready? And again, college career life ready for any student.
So the question is rather, What physics do Iowans need to get through life? That mentality might rule out relativity, but not motion and forces, like Victor says.
My gosh, to the layperson, physics is absolutely necessary. It helps you to prevent a car accident. It helps you to make choices of what shoes you're going to wear on an icy day. It helps you, I mean, it's very regular life, sort of real life stuff. But when people hear the word physics, they think, oh, I can't do physics. So they think of, maybe the Big Bang Theory and, something that you'd have to be really brilliant to be able to understand it. But physics is everyday stuff.
The standards, called NGSS for short, are structured so that about a third of science in every grade level is dedicated to physics. It starts in kindergarten with, once again, waves. Kindergartners might put tissue paper on a speaker and watch how sound waves move matter. In first grade, it's astronomy and the basics of forces, push and pull. The atom enters the scene in fifth grade, although not explicitly. Kilabarda explains.
When you get into actually looking at matter, you'll see that, again, they don't call them atoms, but they start talking about small pieces can be put together to make larger things. So you'll see teachers that will use Legos.
Then you get to middle school. Students are introduced to Newton's laws, heat, and gravity, and the list continues.
One of my favorite things, and this is very higher level thinking, but some of my kids get it, is to Einstein's thought of the universe as like a trampoline, and so gravity, things aren't as they seem. I teach gravity with a gravity table and putting different masses to see how they interact with each other depending upon the mass of the object. So that's very theoretical and blow your mind crazy when you think about, we don't like a trampoline, and then I'm talking about emptiness of space. How can that work? But the students get the idea because they understand a trampoline.
Now, in high school, things get a bit complicated. I spoke with Brad Jacobson, a physics teacher at Central Academy in Des Moines.
It used to be that Des Moines was more physics first. So as a ninth grader, they would take physics, and then they would go on and take biology and chemistry. And they're trying to give students more choices in that. And so you still have some ninth graders taking it, you have some seniors taking it. So at some point, they should be getting some of the basics in physics.
Many high schools offer advanced placement, or AP Physics, to prepare students who seem interested in studying science as a career. The classes, therefore, begin to err away from what do all students need to know, towards what do students who want to study science in college need to know. Nonetheless, the NGSS still apply, and in the Des Moines Public Schools, those standards manifest in a high school conceptual physics course.
A frictionless ramp.
Looks like you don't.
A friction. Oh, so we can find the gravity first since we have the mass, and then we know that the up component of that is the same as the up component of that. Right?
Throw things at me. I won't be able to catch
So the force gravity is 200 newtons. So
That
it's
was one of
200
Jacobson's
whatever.
students. He and his group members scrawled equations and diagrams on whiteboards as they investigated the movement of a box as it slides down a frictionless ramp. This is an example of an unbalanced force. Jacobson himself teaches an advanced conceptual physics course offered to particularly eager middle school students.
So it's what they would have at the high school level. We only do first semester. We cover constant velocity, constant acceleration, balanced forces, unbalanced forces, momentum and impulse theory, and energy. And then the rest of the conceptual physics they would cover, they do a little bit of optics, they do a little bit of circuits, they do a little bit of some of the other stuff that you typically would see in a physics classroom.
So there you have it. A brief inventory of the physics content the Des Moines Public Schools expects its students to know by graduation. But the NGSS aren't just keen on spoon-feeding the facts to students. That's why each core idea is accompanied by an additional dimension, an overarching scientific practice, one that teaches the students how scientists and engineers interact with each other. This includes making graphs, asking questions, or developing models to describe phenomena, among others. Adam Puterbaugh, the K-12 science coordinator for the Des Moines Public Schools, says that This is the penultimate goal of teaching science.
I'm much more into developing critical thinkers than digging into a lot of the nuances of different sciences, just because you're never going to be able to cover it all. And if you can create a student who can think for themselves and who can engage in those big questions and actually know how to interact with information to, develop some answers, you're going to be far better off.
This is Lorian McAnulty for the Drake School of Journalism, signing off. The introductory music was from Lord's song Ribs, and the rest courtesy of Creative Commons.